Welcome to today's session, the Vigenere cipher introduction and its C implementation. The Vigenere cipher is a polyalphabetic substitution cipher that encrypts text using multiple ciphers based on the letters of a keyword. This approach, invented in the 16th century by Blaise de Vigenere, it strengthens encryption by avoiding patterns that could make simple ciphers vulnerable. Its strength lies in using a keyword to vary the shift for each character, making it effective against the basic frequency analysis. Here is how the Vigenere cipher works. We start with the keyword that determines the shift for each letter in our plain text. For encryption, we match each letter in the plain text with a letter from the keyword. If the keyword is shorter, we repeat it until it matches the length of the plain text. During decryption, we simply reverse the shift. We retrieve the original text using the same keyword. The encryption formula for the Vigenere cipher is as shown here. Ci is equal to Pi plus Ki mod 26. For decryption, Pi is equal to Ci minus Ki plus 26 mod 26. Where Pi is the plain text, Ci is the cipher text, and Ki is the keyword letter shift. In the modulo operation, we are using the modulo 26, which ensures any result remains within our 26-letter alphabet. Now let's look at how we will implement the Vigenere cipher in C. We will follow these 5 steps. First, we will take the input for both plain text and keyword. Next, we will adjust the keyword length to match the plain text by repeating it as necessary. We then encrypt the plain text by applying the Vigenere formula character by character. For decryption, we reverse the process. Using the decryption formula. Finally, we display both the encrypted and decrypted outcomes. This is an example for Vigenere cipher. In this example, we are taking a message attacked at dawn, and we are taking the secret message as a key, and we are taking the number key according to its letter. So let us take here the letter S, and the number of the letter S is 18, and the letter of the number T is 44. Here E is 4, E is 4, C is 2, R is 17, E is 4, T is 19, M is 12, E is 4, S is 18, A is 0, G is 6, E is 4. So we are taking the numbers to their corresponding key as a secret message. So these are the alphabets which starts from 0 and ends with Z with 25. So we are taking each one of the alphabet with their number. Then we will convert in the form of a ciphertext. Let us take here the letter which we are taking starts from 18, from A to get S in difference table. Let us take, if you are taking this one, we are getting A to S. If you are taking from T to get X, the count we are taking 4. So T, if you are taking the 4 letters from here, from T, 1, 2, 3, 4. So we are getting X. Let us take T to get V. So we are taking T to get V. We are counting only 2 letters. Let us take here 17. Let us take here A to get R. So let us take A to get R. We are taking the 17. So here we are taking the R, the number, the value, the alphabet we are getting for the 17 is R. Like this, we will convert each plain text to its corresponding ciphertext. So this is the Vigenere cipher. Here we are taking the plain text hello. The keyword is key. By applying the Vigenere formula to each character, we are getting the ciphertext. Then whenever we process the reverse to retrieve the hello from the ciphertext, we are using the decryption formula. So the encryption formula is Ci is equal to Pi plus Ki mod 26. To decrypt the formula, Pi is equal to Ci minus Ki plus 26 mod 6. So by using these encryption and decryption formula, we will convert the plain text into ciphertext and vice versa. Let us discuss about the advantages and disadvantages of Vigenere cipher. The Vigenere cipher's main advantage is that it restricts basic frequency analysis thanks to its use of multiple shifts across the text. It's also simple and effective for text encryption. However, the cipher is vulnerable to advanced cryptanalysis methods, especially if the keyword is short or if the ciphertext is long. Also, keeping the keyword secure is essential, as anyone with the keyword can decrypt the message. With this, we will conclude the theory part. Let's implement the Vigenere cipher in the coding part. Let's discuss about the coding part here. We are taking here the library files. The headers and function declarations here we are going on. The header files provides necessary functions. stdio.h for input and output operations, ctype.h for character operations, for string string.h for string man functions, and stdlib.h for the functions like exit. And here we are using two functions, encipher and decipher. Let us discuss about the main function. This program provides a menu with three options: encrypt text, decrypt text, and exit. And here we are taking the user input. The user selects an option here. And here we are using the three function calls for encipher and decipher and exits. Let us take here encryption function. This is the encryption function where we can take input as the plain text and we are taking the key as the input and we will print the resultant ciphertext. For this, we are using the function here. The formula here we are applying is equal to C is equal to P plus K mod 26. P is the plain text letter 0 to 25. K is the key letter. The position of the key letter is starts from 0 to 25, which adds 65 to the result to convert the value back to the uppercase ASCII. It can resets J to 0 when it reaches the end of the key, ensuring it repeats as needed. Coming to the decryption function, we are taking the ciphertext key as an input and we will print the resultant plain text here. For this, we are using the formula P is equal to C minus K plus 26 mod 26. C is the position of the ciphertext letter and K is the position of the key letter. And we will add 65 to convert back to uppercase ASCII. And key wrap around, it rejects J to 0 when it reaches the end of the key. So like this, we will convert plain text to the ciphertext and ciphertext to the plain text in the Vigenere cipher. This program demonstrates basic encryption and decryption using the Vigenere cipher and enables user interactions through a simple menu. This is about the today's session. Thank you.